Hello everyone, welcome to this presentation about BIM Essentials for Project Managers. I'm Mostafa Elashmawy. I'm a Senior BIM and Digital Delivery Consultant. I have Master in Global BIM Management and I'm certified from several organizations for BIM management and also certified for some of the BIM software. In today's session, I plan to give a brief idea about many of the most important BIM expressions, terminology, and concepts that are essential for every project manager working in construction projects. So I know it might be an easy question nowadays, but I remember back when BIM was not really understood, and at that time it was not a common word, and there was difficulty in understanding what it stands for. Currently, BIM is well known as building information modeling, but what's actually coming to our minds when BIM is mentioned in projects might differ from one person to another in a construction project. However, from my point of view, the best definition to BIM was mentioned in the International BIM Standards ISO 19650, which says that building information modeling is the use of shared digital representation of a built asset to facilitate design, construction, and operation processes to form a reliable basis for decisions. So the word facilitate is the key in understanding what's BIM. So BIM is anything using digital representation for our asset to facilitate all our processes. When I speak about BIM for PMC, I'm referring to project management consultants. However, this is also applicable for any project managers at any organizations. So as you can see on the left, an example for hierarchy for a specific project. So you have clients, you have PMO, PMCs, you have lead design consultants, contractors, supervision consultants, and many other stakeholders involved in the project. But for you as a project manager, you need to understand that from BIM standards point of view, all of these stakeholders' responsibilities when it comes to BIM can be illustrated based on this shape on the right. So this is a simplified version of ISO 19650 part 2, figure 2, but coming from the UK BIM framework. In this diagram, you can see this symbol A that represents the appointing party, and then there is symbol B that represents the lead appointed parties. So lead appointed parties are any parties that are directly contracted by the client, which is appointing party, and then there is some appointed parties that are contracted or led by the lead appointed party. So the relationships and the responsibilities in BIM are based on this diagram. So anyone that have contractual obligation to direct contractual obligation for sure will have BIM requirements and BIM deliverables, and the client would be responsible for reviewing them. When we also speak about the contractual requirements, usually we have a group of documents that are usually generated in the project. So we have BIM management plans, we have exchange information requirements, we have BIM execution plan, we have the BIM standards, and we have the models and asset information requirements, and for example, other BIM deliverables like 4D simulations. If you have a look here and look at these entities on the right hand side, the client, project management consultant, lead design consultant, general contractor, just for a while before I reveal the answers, imagine which of these documents have the most strength inside a construction project. So which of these documents will dictate the requirements and the other documents will follow, and which of these documents are prepared by which entity. Mainly, the most important documents in a project are the exchange information requirements and the asset information requirements. Exchange information requirements are usually responsible for setting the information through the delivery part of the project, which is design and construction. And then the asset information requirements usually puts the requirements for the handover requirements. So the BIM models that will be submitted at handover for the purpose of the asset management after handover. And both documents should be supplied by the client as part of their contract. Another important document, however, it's not very common, is the BIM management plan. This is usually done if you have a separate project management consultant in your project. If not, usually the BIM management plan would be done by the lead appointed party. And sometimes if you have only one entity delivering the project, maybe it will be replaced by a BIM execution plan. So if you have a BIM management plan and the BIM execution plan, the main difference between them is that the BIM execution plan will tell how things will be done in the project to deliver it, while the BIM management plan usually done by the project management team to explain how they will manage the process. Thinking from a project manager or a project lead perspective, I would look at the exchange information requirements and the asset information requirements to ensure that these have enough data about the client's requirements, and then I will ensure that the BIM execution plan responds to these documents to specify how the consultants or contractors will deliver the project. When it comes to the BIM models or 4D simulations, usually these are deliverables by the general contractor or the lead design consultants, depending on the project stage. BIM standards. You might hear your BIM team always speaking about ISO 19650, but for your information, ISO 19650 is not one single document. It has several documents, and these 5 documents are what's published at the moment. Part 1 is about the concepts and principles. Part 2 speak about the delivery part of the project, from start of the project till the handover to facility management team. And then the part 3 speaks about the operational phase of the asset. And then part 4 speaks about the information exchange. And part 5 I speak about the security aspect and how to control the data from a security-minded approach. One of the most important terms that's usually used are BIM uses, and sometimes it's digital uses. When we speak about this, we are speaking about the uses of BIM. So we will use, for example, BIM for augmented reality. We'll use BIM for collaboration. We will use BIM for 4D and 5D simulations. We'll use BIM for site inspections. We'll use BIM for site coordination. So these BIM uses comes from the BIM goals that the client has set at the beginning, and any additional BIM goals that any organization involved in the project would have as part of their BIM execution plan. When we speak about BIM software, we need to understand that there are lots and lots of software in the market. There is no one single software that's responsible for delivering BIM. Consultants and contractors would usually tend to use their preferred tools. So there are tools for authoring, there are tools for coordination, there are tools for quantification, there are tools that's used as a common data environment. So you need to understand that it's not only about the authoring tool. So for example, if we are speaking about Autodesk products, you have Revit as the authoring tool for buildings. You have Civil 3D as the authoring tool for infrastructure. We have also Navisworks for coordination. We have Autodesk Construction Cloud as a common data environment. Same happens also at other software providers. Many have software for different purposes. So when we speak about BIM software, you need to understand it's not one single software that will do all the BIM functions. Then an important term that we usually use is the BIM exchange formats. And when we speak about BIM exchange formats, we are referring to the file extensions, for example. So we have Revit files, we have DWG files, we have Navisworks files. So all of these are exchange formats, and in our world, every software provider have their own files extensions, but it's essential for us as BIM experts to strengthen our support to this format, which is the IFC format. IFC format is a format that's understood by almost all BIM software, and it's important to ensure that all our consultants and contractors and all our platforms can understand our BIM models. So regardless which software your consultant or contractor are using to deliver BIM, try to request an IFC format as the formal deliverable to ensure that it's usable in other BIM software and in other platforms also, like GIS, like future management systems that will be used by the operation. When we say federated model, we mean that the combination of all the models in a certain project or a certain area. And BIM experts, when they plan for a project, they need to plan for their federation strategy to avoid unnecessary clashes. So from the beginning, we need to define spaces or volumes in our project dedicated to specific disciplines or specific contractors or specific consultants to avoid clashes from the beginning. So instead of clash detection and resolution, we target clash avoidance. And this is very similar to this Suma cube on the right hand side, where we need to ensure that whenever we get all the BIM models from various sources, it can fit together with minimal clash. One of the common processes of federation is that we export from the native format into Navisworks formats and then collate these NWC files into an NWF file and then export it into an NWD format. Common data environment, from my point of view, is the heart of BIM. So when we develop a common data environment, it's not only about selecting a platform. So you can just say, I'll choose Autodesk Construction Cloud as my common data environment, and then you think that you have finished your job. No, selecting a common data environment means that you need to develop a process for this common data environment. Who will provide this platform? Usually it's the appointing party, but you need to define that when it will be provided to everyone. Usually it should be at the earliest stage of the project. Then you need to develop some CDE manual and information protocol. We need to define naming conventions and information states, what will be the metadata in this project, and the revision codes. So all of these are part of the common data environment implementation. It's a software solution plus a process. And usually any common data environment will follow this standard process as per ISO 19650, where there will be many work in progress places per task team, and then once the data is approved for sharing, it goes to a shared folder. Once it's reviewed and authorized for publishing as formal documents, it's then transferred into published, and any common data environment must have an archive for all the versions and the revisions of any document. In the market, there are lots of solutions there. There is for sure Autodesk Construction Cloud, which also includes Autodesk BIM 360, and there is Innate, ProjectWise, Procore, Trimble Connect, Oracle. Sometimes we would consider your local server or SharePoint as common data environments, but still, when you are selecting a tool, you need to understand that there will be pros and cons for each tool, and then you need to decide which tool is the best for your situation. BIM and GIS integration is something that's growing rapidly in the industry. So if your project have a GIS team and BIM team, you need to understand that BIM and GIS need to work together. So this can be through developing maps, developing dashboards that have both the BIM models and the GIS models. So you need some coordination between the BIM and GIS to ensure that BIM models have the correct geolocation, BIM models are fit for GIS environments, and ensure that both are talking to each other properly. Now, when we speak about the future of BIM, we need to understand a specific concept called digital twin. Digital twin is somehow old concept, but recently it's being used in the construction industry as the evolution of BIM. So digital twin is basically a digital replica of a physical asset or a process or others. But in the construction industry, mainly we usually hear that some BIM experts would say about their BIM model as a digital twin, but usually the main difference is that digital twin would require a link between the digital asset and the physical asset, and ideally this link will be in two directions, so you can get data from the real world, put it into your digital representation, do analysis, do all kind of data mining, and then take decisions based on that, and then you can send these decisions in the form of clicking buttons or to control the physical world. So it's not that BIM is totally different, but BIM for us can be the core of a digital twin that's used either for the management of the asset after handover or for the management of the construction project at the construction time. And another important topic we need to always consider whenever we speak about the future of BIM is the artificial intelligence. Artificial intelligence is being used for everything at the moment, and the uses of artificial intelligence is developing very fast. So we need to consider and keep our eyes always on the developing cases for AI supporting BIM, whether it's for helping in the BIM production or helping in the standardization of our BIM deliverables. In all cases, AI will have a huge impact on BIM in the upcoming years, and we need to always keep ourselves updated about these. Thank you, and if you have any questions, I'll be happy to answer it. You know, I'm always available on LinkedIn. Thank you.